Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kinda dark, but it's not that bad. These water worlds are more interesting than they may seem. So let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.0025%. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it will have a rocky surface. If it's bigger, it will turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small, dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our sun and 300 times dimmer. Scientists wouldn't worry about it at all. But back in 2009, they noticed that this star has one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier. But at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it. But it wasn't a gas giant either. Well, actually, we only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far scientists haven't been able to find anything there. No hydrogen, no helium, no water. Nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.14 astronomical units away, which is less than the distance between the moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250–535 degrees. Whew, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling, without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? That's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So, that's it for the creepy Gliese 1214b. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of Super-Earth. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though. This ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars, so potentially, yes, there may be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There also should be some micro-elements and minerals, and unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up! There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability is that they'll bring something like this into the ocean, and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there, but if it exists, then surely something could have originated there. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, 2 teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole. A blank void with no galaxies, stars, planets, or asteroids. Literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Bootes void. It lies in the constellation of Bootes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing. but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boots void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri E. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri E is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the diamond planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense? It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000-plus exoplanets we have already discovered.
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way, as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our Sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found two supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else, the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare, massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old. But the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby, so what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and a billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope: 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some super glue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, another one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons Itai to the Thuri and Ifaru, but let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons, to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur, though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the 4. It's comparable in size to the moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in 2 ways. The first is through congelation, a rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into a freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you then take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents, hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's the potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd manage to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size but having only half its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited. It's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection. But because of its quirky tunes, Ganymede was soon nicknamed Jupiter's Singing Moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the farthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active, but scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features lower levels of radiation. Given this suitable environment, we may end up setting a human base for future exploration here one day. Dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the laws of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future circular collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink wink. It's a crazy massive region in space, about 10 million billion times the mass of our sun, with a super powerful gravitational pull. Scientists think it might be a supercluster of galaxies, but they're not sure. The problem is that we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 595 kilometers per second. Just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled towards this region, even though, since the universe is expanding, they should be moving apart from each other. What's even weirder is that this Great Attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 100 meters to about 1 kilometer long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed the sun, it unexpectedly sped up, and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua since then. But after a while, it turned out that it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years.
Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis
that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that, with trillions of planets, there will be no planet like ours anywhere. But then, a geologist Peter Ward argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all its astrophysical and geological conditions, should line up perfectly for complex life to develop. Just think about it. Being in the right zone of the galaxy, on a good distance around the stable star, a rocky planet with water and right atmosphere, emergence of molecules, monkeys deciding to walk, and so on. This would also explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter, dark matter. And even if they do exist, we could be incredibly far away from each other. This would make communication or contact with other intelligent species very unlikely. There's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe. Although he assumed that it's not because our planet was a result of tons of unique conditions, but because there must be some sort of filter that reduces the chances of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it, or somewhere ahead in the future, which means we might go extinct like many species before us. Maybe the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up. Potential catastrophes, resource exhaustion, or other challenges. There's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. In space, you can often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size, but the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kinda like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. We found a water cloud in space, around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic, supermassive black hole. This quasar is about 20 billion times larger than the sun, and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud, and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that water isn't young at all, and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. So get this, Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So how did this time warp happen? Well, it's all because of this wonky line. This is the International Date Line. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first. It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west, and boom! It's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think the International Date Line would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 4 kilometers apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 1061 kilometers across the date line from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it is already Friday. Yep, we are talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Date Line look so ridiculous in the first place? Great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, and it takes about 24 hours or a day to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Basically, people needed to figure out which of these 24 zones, or lines, would be the starting line or chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines, called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages had to just wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States, with one big goal: to decide on a line that would serve as the official prime meridian. Finally. Like it or not, they were determined to create the International Date Line that the whole world would accept and follow from that point onward. The prime meridian was established in Greenwich, England, and the International Date Line was placed on the opposite side, running through the 180th meridian. Sounds simple, right? But that's when the nightmare really began. The chosen international dateline didn't just wander through uninhabited areas. Oh no, it split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is 1 day ahead and the other half is 1 day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sit just west of the international dateline. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the dateline. Suddenly, Kiribati was straddling the international dateline. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. To fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So, Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's came a day early. Woohoo! After that, the dateline moved eastward to go around the entire country. The same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit zigzaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international dateline, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. In the end, the international dateline looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. UTC never changes for daylight saving time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of standard time to make better use of sunlight in the spring, summer, and fall evenings. The idea was so brilliant that most countries jumped on board. But not everyone. Just look at Nepal. They have never, ever used the daylight saving time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zones. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 3,000 kilometers from west to east. So, it should have 3 time zones in total, but they have only 1. This means that the sun rises almost 90 minutes earlier in Dong in the far east than in Gujar Mote in the west. And why do they only have 1 time zone? Well, basically because they can. Just remember that the international dateline and time zones are invisible, artificial, and, now you know, totally arbitrary. So if a country wants to stick with just 1 time zone to simplify processes and business operations within its borders, then hey, why not?
At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard Worlds Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri e, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri e had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri e might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, Some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri E, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pulsar, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pulsar in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where two massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets like Corot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve.
Now see here, astronomers have recently discovered a neutron star, aka a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe, and it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 19 kilometers wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like neutron gnocchi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going even deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So, inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penne. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system, 4U 1820-30, located in a dense star cluster, NGC 6624. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second but a minute, it'll be over 42,000 rotations per minute. At the same time, the newbie ties with another neutron star, PSR J-482446, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait, we can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast, too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. You might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, 4U 1820-30, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. Haha, no accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface. Eventually, it triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than the Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer, and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and, thus, confirmed its extreme rotational speed. But wait, the best part is coming! While neutron stars are already extreme, there's another class of them that takes things to a whole new level: magnetars. Magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000